Welcome back, folks, to the Get a Grip on Lighting podcast. On today's show, we have BD Erickson II. BD is a proven leader and team builder, successful in navigating ever-changing high-tech business climates. Having business and science degrees combined with Tony Robbins' Mastery University, he's a badass. Highly technical sector of clean renewable energy and clean manufacturing, spanning 2 decades in high-pressure leadership roles. BD has been recognized multiple times for building winning teams, standing cultures, massive impact on growth. Currently running SaticShield, the country's leading clean power manufacturing facility and Montana's most proficient solar company. BD possesses a proven track record of sustaining a high-level team buy-in. He's going to talk about it on the show. But before we go there, Greggy, we got to go to the easy folks at Keystone Technologies. Go to KEYSTONETECH.com. Greg, Light Made Easy.
Yeah, talking about making it easy, they're doing one high bay fixture that you can stock and keep on your shelf and cover multiple applications. Power and color selectable. 3 options in terms of lumens and wattage. It's 18,000 up to 30,000 lumens. 2 Kelvin temperatures, 4K and 5K, 100,000 hour life. All built into the same fixture, so switchable, easy. Put it on the shelf, put it in the field, install it. Let's go.
You got to go to KeystoneTech.com. That's KEYSTONETECH.com. Light Made Easy, the Retrofit Kings. Keep it easy with Keystone, Greg. Of course, proud members of the National Association of Innovative Lighting Distributors. That's NAILD.org. Join us. If you're a lighting distributor, what are you waiting for? That's where it's at. But for right now, BD, what's happening, brother?
Surf's up. Nice to be here, boys.
Hey, I'm gonna throw you a nice easy softball and start off with your business here. What is dirty electricity? Give it to us. Break it down.
So dirty electricity is a real thing. It is measurable. When you have electricity coming into your home or facility, it's got to be within some standards, right? So if you plug something in and it's a 120 volt outlet, it needs to be 120, man. If it's 200 volts, it's going to fry whatever you have in it. In the US, we're at a frequency of 60 hertz. In Europe, they like 50, right? When I was a kid, when my mom would be cleaning the house, I'm watching, Gilligan's Island or the Brady Bunch, and my mom would vacuum. It put lines. You were right there watching Carol Burnett and Braves baseball, right? TBS, baby. That's what we grew up on. So when my mom would come in and vacuum, it'd mess up the TV. Well, I'm an 8-year-old Jedi, so I jumped for the rabbit ears. I'm old, man. I'm older than you fellas a little bit. That's how you got your clear signal, right? I learned as an adult it had nothing to do with the wireless waves. Clean electricity was coming into my mom's vacuum. She was distorting it with the use. You can hear your sister's blow dryer on your radio. Don't say you can't. You can. It's a real thing. Ham radio guys always want this clean electricity. So there are things that happen to your electricity that make it dirty. One is interference. That's like crosstalk, right? One is distortion. So every LED driver, every CFL ballast, and every solar inverter has a rating on it, THD. Should be THD less than 3%. What's that? Total harmonic distortion. So oftentimes the quality of your ballast, the quality of your driver is in direct proportion to a couple things. One is THD, total harmonic distortion. Another one's power factor, right? So in electricity, we have 8 key points. And I don't mean to be techie, I'll buzz through them fast. 1, volts. 2, amps. 3, watts, which is the product. Total harmonic distortion, electromagnetic fields, Ohm's law of resistance, and primary frequency. These are the 8 things that need to be within a parameter. So dirty electricity is when one or multiple things are out of design parameter.
Got it. And what's your background? Are you an engineer?
I didn't finish an engineering school. I was slugging it out. I do have an applied science degree and a business degree, and I was in apply power systems engineering certificate program when my life changed a little bit, and I did not graduate. So I've been to school. I've got no certificate and won't fib about it. But I can slug it out with the best of them in my little sector. But a lot of that I didn't learn in school, guys. I learned it on the job. I mean, when you go to business school, you learn about insurance and Jimmy Hoff and all that stuff. How much do you really get to apply in the real life world? For most of my lighting and my engineering, come on, guys, I did not learn it.
I'm going to say something right now. I'm going to tell you something right now. I think college is 90% a complete waste of time, and it costs way too much money, and they don't teach you anything you need to know. And the sooner you get out, is if you want to be an entrepreneur, get out there and start selling stuff to people, and you'll learn so much fast. I mean, you know what? Especially in America, what's your degree? Do you have the tickets beside your name and all this? It's such a load
Yeah.
of crap. Americans, especially, way overvalue formal education in universities, and way undervalue savvy learned in the business world.
It's like a rite of passage, and it's, you ask somebody, about their education, and in some way that, you know puts them in a group, or their credibility or something. When you're absolutely right, I know guys that right now their shoes untied and their zippers down, but they got an MBA. I got a
Yeah.
good buddy who's an MBA. He is washing dishes right now at a restaurant. I also know guys that didn't graduate high school that are multi-million dollar entrepreneurs. College is absolutely overrated. For some reason, we give it so much credibility. That's the American system, right? We give certain things credibility. When what should really give you credibility? Are you a good person? Are you fun? Are you honest? Are you generous? Are you kind spirited and kind hearted? That's the only measure of a man, I think, is the size of his heart. I
Well,
truly
nah,
believe
I
that.
would say, what have you built? What value have you added to the society? Like, listen. There's so many
Contribution?
grifters and talking heads out there that have tickets that say something. Oh, I'm smart. Look at, I have a ticket from
Right.
here. And I'm not going to.
I
This we could
agree.
talk.
I,
We could do a
I
whole podcast on
absolutely
this
agree.
topic. I think it's a
You're correct.
huge problem in America right now, and in Canada too. Like, you don't have a degree or whatever. It's like, ah. Anyway, long story short, yeah. What's next, Greg?
BD is in
Let's get.
agreement. Okay, keep going. But I
So
do
we
have
know what.
science and business degrees, if that helps at all for
Yeah.
our listener.
No,
But I
just
when I
just
learned it
curious.
when
Yeah.
I learned at work, I learned at work. I didn't learn it in school.
Sure.
Yeah. No, that's the right way to do it. So dirty electricity. You said a little bit, but specifically, why is it bad, or is it a major problem? Let's go there.
Okay, so let's go back. So just so you know, maybe the single largest contributor to dirty electricity in our world today is in direct proportion to our lighting. So we're going to go back just 30 years, maybe to 1990. We all use the Edison incandescent light bulb, right? You got an anode and a cathode, right? You got power in, power out, and then you have this tungsten or magnesium, manganese, some blend, usually tungsten filament. And when you apply voltage, you get heat. 90% of what's made is heat, but you get this really great byproduct of light. Now, by the sheer operation of that, it cleans electricity. So my mom's vacuum is on making it dirty, but that resistive load cleans it. Now, according to the Department of Energy at that time, we all had 20 to 30 of these light bulbs in our home. So every single resident, American, Canadian, Mexican, you pick it, is actively cleaning electricity every time they're using light. Now, they took that away and they brought this really great product to us, CFL, compact fluorescent lamp. So they shut down all these. So I am an American designer, engineer, manufacturer in Montana. We manufacture our stuff in Montana for the most part. Some little parts always come from Asia. We don't make every component, but I think it's important to build stuff, to be a producer, a creator, a contributor, not just a consumer. So what happened with the CFL, those are made in Asia. So these great light bulb manufacturing plants in Michigan get shut down. We're buying the stuff from Asia. Well, what's in it? It is um, so the way a compact fluorescent works is you have gases in them, and that gas becomes your filament. I don't know if you guys realize this, but they need higher
This is
voltage.
a
The
lighting
way,
show. Everybody listening mostly knows all this kind of thing,
okay, I
right?
love it.
So
Okay, I
yeah,
love it.
yeah,
So
yeah.
we import this terrible crap, and then we throw it in garbage in landfill in Montana. Man, it's such a terrible waste. But these things don't clean electricity, gentlemen. They dirty it. They add harmonic distortion. They
Mhm.
add electromagnetic fields. They have low power factor, maybe in the 50s. So they take less watts. That's true, right? But they add harmonic distortion, electromagnetic fields, and low power factor. So a lot of what we gave back. But something very diabolical happened there. We went from everybody having 20 electricity cleaners to everybody having 20 electricity dirtiers. And a lot of the discussions in Europe were, okay, we lowered overall wattage by the switch in lighting. However, we have so degraded the quality of power that we're now pushing more power than it requires. And that's what power factor is. When you need more power than is actually required by the device to run. So now you begin to lose power because of Ohm's law of resistance. The more current we push, the more we lose as heat. And then where's the heat go? Turn into pixie dust? No, it's heat. So now your phone's hot, the back of your DVR is hot, your TV's hot, back of your fridge is hot, your phone charges slow and hot. Now my air conditioner is blowing to beat the band, and the top of my damn DVR is now a space heater. So the electronic doesn't last as long. The electronic doesn't want to be hot, and my air conditioner is shrugging all this heat. So the change in lighting had a fundamental change in energy quality in the world beyond contestation.
Well, that's true. I thought the solution was to increase the size of the neutral wire at the switchgear or at the main. What we solved a lot of these problems. So companies would switch from their magnetic ballasts, their T12
Yeah.
ballasts, and then they would have problems. The whole building would go down, and the problem was that the neutral wire was smaller than the at the switchgear was smaller than the load wire if the building
conductor.
was built in the 70s or whatever. And so we would change those cables, and it would solve the problem. But you're saying the problem's not solved?
I love that you guys actually do know your stuff. I usually talk everyone's head. I throw it, you guys hit it back. I love it. The neutral was never supposed to be that big. The neutral was not supposed to carry so much current. So we've got these houses in California specifically where the neutral on the ground is bonded. That was code now. Having neutral and grounded is not code anymore. So I plug in my vacuum, and in the phase blade, so when you're looking at an outlet or something that I would plug into an outlet, a plug, usually one blade is small, the other blade is big.
Sure.
Smaller blade is the phase, that's power in. The big blade is power out. When you throw an amp meter over both legs, you got like 5 amps coming in. You got 4.9 going
Sure.
out, baby.
You got
The only
amps going
power
out,
that's
yeah.
really lost is Ohm's law. Well, where does that go? That goes on the neutral. So the neutral becomes the conductor, if you will, of the dirty electricity because we got clean power in, degraded by use of the device, out on the neutral. So the
But that's
more
not
things that we do-
consumption, though. That's not consumption.
No,
though.
it's not consumption. No, it's not consumption. But dirty electricity has that cumulative effect. And that's really what I'm talking about, really not watts or power bill specifically.
Okay, so listen, I've had people come try to sell me black boxes before they clean electricity. And I always call bullshit. I love call bullshit on them, okay?
I love it. Okay.
So one of the things that, I've done in the past is we've actually metered lighting systems and then took our payment out of the proven electricity savings. And we've never seen any electricity savings on consumption or load from any of these devices that scrub the electricity or clean the electricity. So we're in agreement that there's no energy savings.
Well, not on that device. Not on that thing. That any energy savings that you would have would come post that as a result of the dirty electricity. The watt should stay the same. Volts times amps times power factor is watts, not volts times amps. Volts times amps is VA, volt amps, total power. So by cleaning the power, you're not going to reduce or improving the power factor. You're not going to improve the watt. That's going to stay the same. What you're going to lower is heat down the line. So what I'm stating right here is that I've got a ballast, I've got a driver, I've got something. We measure power in, power out, and we filter it. Who gives a shit? That's the guy that dirtied it. And do you want to put a filter on your Camel, or do you want to stop smoking? That's really the difference too. That's a different part of the conversation.
Let me ask you a question. So if I stick a meter on the whole service, before it's a component you install at the panel that you guys are making, or what is it? Tell me what it is you're making. Let's start with that.
Yes. Okay. Well, let's finish what you're saying. So okay. I don't argue that you don't change it on the device that's making dirty electricity. What's changed is the other things that now get the dirty electricity. My mom's vacuum comes in. My mom's vacuum's getting clean power. It's my TV that's feeling the effect. So I go up to a river and it's snow melt in Montana and it's gorgeous and that water is so clean I can drink it. And I am also dumping a contaminant into that water, measuring it right before at the place. That's not where it's dirty. That's not where I'm going to pick up the contaminants.
But that's how we're going to get the baseline.
That's how we're going to get the baseline, handsome. Okay, so now my DVR or whatever it is using 3 or 4 more extra watts. That's
Hmm.
real power. That's converted into heat. Heat is the watt. You cannot cheat the
I
watt.
agree with you. I agree with
You
you
can't
100%.
cheat the watt.
Okay, so
So what I'm
if
saying
I
is the
if I put if I
savings
meter
is
before and
downhill.
after, if I
Yes.
meter the panel, the entire service to a home or a business beforehand, and
Yeah.
we like what is it that you would install and what would it do?
Okay, so now we're getting somewhere. Okay, so let's say we install this at the panel and we've got a clamp over. So in the US, we have 120 on A and we have 120 on B. So let's
Hmm.
throw a CT clamp over A and B and let's measure the 8 things I talked about. We're
Hmm.
going to measure volts, amps, watts, all that. And then we plug in a whole bunch of dirtying devices, CFLs with bad ballasts, LEDs with bad drivers, just a bunch of vacuums, just a bunch of crap. And we measure watts, amps and watts at the panel to power these loads. And then we filter it with any number of filtering devices out there that work. Within a few minutes, you'll begin to lower the heat loss, the Ohm's law, the total power, and the amps, and that it will lower the watts considerably at the main service as a cumulative effect of all these things, not necessarily that one thing specifically that's making it dirty.
So that I have tested these things multiple times and I've never observed that. Now I'm not
We
saying
at
your product. I'm not saying your
no
product,
no
but
problem,
I've
no
tested
problem.
it. I've done the tests on this. I put the CTs around
So
the
what you're
main
saying
loads.
is that I'm going to put a meter on your house, and I'm going to ship you one of my units, and I'm going to show it to you unequivocally beyond contestation. If you'd be willing to play that game, I'll play it with you. And here's an easy way to do it. So there's guys out there. So what you're probably talking about, for the most part, is probably a capacitor bank, right? So a
Hmm.
capacitor
Sure,
bank is an easiest way to lower amps, but we know the amps don't lower the watts. What you
exactly.
do save though is resistance. So an air conditioner runs on 5 amps at a power factor of 50. You improve the power factor to unity 99, you're going to be down to 2.5 amps. So those 2.5 amps, just by surely traveling through the wire, will have a savings. You can't say none. It's small, but you can't say none, because if I push 5 amps from here to here, I'm going to lose more to Ohm's law of resistance and heat than I am 2.5 amps. It's
How much
totally
does the
linear.
device cost? How much does the device cost?
Well, it depends on what the load is or whatever else. So for
Single
a
family
thousand
home.
bucks,
Single family
thousand
home.
bucks,
Thousand
thousand
bucks.
bucks.
Okay.
So let's keep going. And so we make lighting and stuff too, and our lighting is power factor perfect, adds no THD, adds no EMF. Um, there are a lot of other results that come as an effect, a byproduct of this dirty electricity. So your water, for the most part, right? You're a human being. We're 70, 80% water content, right? We get heavy metalled. People say chemtrails and aluminum and all this stuff. So now, come on, I'm just saying what
Mercury
you're
is
saying,
real. PCBs is
right?
real.
So
Yeah.
so so now I'm water and I've inhaled all this aluminum. I'm a conductor, period. So the idea that cell towers and 4G and 5G would have no effect on me is impossible. I'm not saying it's bad for you. I'm not wearing my foil hat. I'm just saying that when you shoot any signal, any wave, where's the wave land? It lands on an antenna, it lands on a conductor. When you are 5'9, 185 pounds of water and metal, you are a conductor, period. So you might not agree that it's bad for you, but the idea that it has no effect is so easily refutable, because that's just how electricity and waves and things work. So if it can make your DVR hot, and it does beyond contestation, if it makes Ohm's law hot and the back of your fridge is hot, and it is, and the back of your freezer in your garage is hot. So a couple things happen. Number one, when we lower that heat, that's the watt, we lower the bill. So as those things cool
But
and
you
less is
also
lost,
preserve the life of the devices. Is that
you
what you're saying?
preserve the life of the device. The thing now runs cooler. Your phone, every 21 times roughly that you charge it, gets hotter than hell. Why? It didn't the last 15 times, but it is this time. We'll help you solve that. We'll help you. Your intelligent brain says something's not right. You don't exactly know what it is, but you know that it's not right. It's not supposed to be that hot.
I
It's
thought the
not
heat.
friggin' good
I
for it.
thought the heat was largely I thought the problems with that were largely the difference between AC and DC. Like the constant converting of AC electricity to DC is
I
problematic.
love you. So the initial biggest cause of dirty electricity, the number one initial cause was our switch in lighting from incandescent resistive load lighting, that clean power, to CFL. Here's number two, boys, the conversion of AC to DC. Right?
Yeah.
It is a huge dirty electricity thing. So now we're strobing. So DC is one guy goes in and you shut the door. I mean, that's how you turn DC into AC, right? You let one guy in and you shut the door behind him because AC wants to do this. Well, that's what a diode does. You let him in, then you shut the door, he can't go out. And then you net the legs again and you shut the door and he can't go out. And so now you're going dot, 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 at 60 hertz. You're strobing it. Your DC device likes it. Friggin' nothing else does. Everything else hates it. And the idea that has no repercussion downstream is bullshit. It does. And we'll measure it. And when you clean it, you get a different result. Does it cut your bill in half? No. It's like 6 or 8%. But it's measurable, it's consistent. And the reason you get that is you're not making all your crap hot. You're not making all your crap hot. And so when your crap's not hot, it performs better. It has to last longer. You're not going to argue that with me. And your air conditioner is not blowing to beat the friggin' band. So let's say it's 80 degrees outside and you got the air conditioner on. Your little kid wants to be warm. They bring out a space heater and they plug it in. You go, no way, Jose, because I'm using watts to make the heat and then I'm using watts to make it cold. Don't think the back of your fridge isn't that same thing. Of course it is. So if I save the watts making it hot, I save the watts making it cold. If your air conditioner can do one less event cycle per day, or shorter event cycles, you save about 3% on your bill. We'll accomplish that almost out of the gate by cooling down all your devices. So we're not talking about
I want to ask you a question
numbers, but they're measurable.
Okay.
They're real. And
Right.
you can tell right now I'm not full of crap because I know what I'm talking about.
Yeah, but that doesn't mean your device works. So we have to talk more about that.
Okay. All right. That's fair enough.
Right.
Okay. That's fair enough.
All right. So here's
because we're going to get there.
Huh. Well, I think there might be part two here, but anyway, let's discuss this further. So I have a farm in the country, okay, and
Okay.
In the summertime they've built a lot more houses out there recently.
Yeah.
And what I've noticed is that in the summertime, weird things happen because I have
Yep.
a ground source heat pump. Watch the volume there, Scotty. I just got it a lot louder on my end anyway. But so I have a ground source heat pump, and I noticed that sometimes what will happen is in the summer at peak heat, my generator will come on, which is super weird. But what's happening is the device that's sensing electricity is sensing that it's gone down. So there's
That's right.
the voltage is dropping because everybody's
right.
in air conditioner
That's
is
right.
going on in that area, and you have long power lines servicing these areas. And there's not a lot of whatever those the stations that redo
Substations.
substations,
Yep.
and that so you have long distances combined with higher than normal loads going on all at the same time, and then the power drops. The drops and it trips on my generator.
Yes.
Does your device clean power on the way in?
Yes. So what you're talking about is exactly what I'm talking about. Now I'm talking about a micro scale. You're talking about a macro scale.
Mm-hmm.
So what we're talking about is something in between the clean power and me, changing in some negative way the parameters of these powers. So what you're talking about specifically is low voltage. Is low voltage a form of dirty electricity? It certainly can be because it's outside a parameter. And now the alert on my HVAC or the alert on my pump or something else is saying not within parameter. It's resetting, turning on my Jenny or whatever else. And so we're going to add that it's a cumulative effect. So their CFL, their DC devices are adding more and more harmonics, real and measurable. So when you get called the foil hat guy, and I can take it, these shoulders can carry it. I've been called the foil hat guy. But when you ask a ham radio guy if interference is real, it's beyond contestation. They have all these filtering systems and stuff so that they can get this clean signal. When you ask an audiophile, so we're in
Like
the
Neil
90s.
Young talks about this all the time. Neil
So
Young,
this guy's
when
an
he
aud-
plugs
this
his
guy's
amp,
a-
Neil Young, the musician, he
Yes.
talks about plugging his amp in all the time and knowing if the power is clean or not
So
by the way his guitar sounds.
Our
Yeah,
best
it's true.
customers are audiophiles. So So bands and stuff love our stuff. So let's say you're in this audiophile's house and you're watching Avatar, and we have drifted away to James Cameron's incredible light and sound, and we're totally encapsulated. Now the mini fridge comes on in his bar. What happens? The speakers go tick. They go pop. Don't say they don't. Of course they do. They can't help it. When that big inrush pulls, that 5 amps goes to that air conditioner.
BD, the worst is printers. Like a printer comes on to print something, and it like takes out anything else that's on that circuit. It takes it out. Yeah, it's true.
So this is exactly what I'm talking about. And so it's one of those things that you just say it out loud. You're the foil hat guy, but then you say, I'm watching I Dream of Jeannie. The TV's messy. My neighbor's air conditioner comes on. My lights dim. The ham radio guy and the audiophile pop and tick in the speakers. This is exactly what I'm talking about. And your phone getting hot. You just had to have it broken down into real simple things that you're familiar with. And so I'm going to take it one step further, and you guys are going to love this one because the UFOs are coming for us, baby. EMF are bad for the person. They're bad for your being.
What's EMF? What's EMF?
Electromagnetic fields.
Okay.
So electromagnetic fields is what makes any motor run. The power of electromagnetic fields, I'm going to put it in proportion for you right now. So I think as little boys, we all love trains, and I would count the cars. And whenever we'd get stopped at the train crossing, I would count them. And my top one is like 111 cars. Well, I'm in Montana. They're coal cars. They were some 20 to 40 tons per car. And you got 100 of them. How do you get that thing going? How do you get that thing moving? Now, we've all pulled a boat or a big trailer, and we used to drive sticks. You're slipping that clutch. Pretty soon you're smoking your clutch because you're trying to get this thing, or your motorcycle. You either do a wheelie or kill it. You got to be smooth with the clutch, right? Well, in an electric motor, you've got a stator and you've got the coil and you've got the magnets, and you create, by applying voltage to this copper coil, an electromagnetic field. That field begins to spin it. Nothing's touching. There's no moving parts or connecting hard parts. So we're going to get 100 train cars that weigh 40 tons each moving with a field. Yes, that's how they work. Electromagnetic fields are real and they're part of everyday life. So let's break it down a little bit farther. What does the grass look like under high voltage lines? It ain't bushier. It's bushy less. It's dead underneath, and then a little yellow, and then it gets green again. It's not healthier. Now, I'm not grass. Grass is way tougher than me. It lives outside all winter. It lives outside all summer. It's tougher than shit. It's hard to kill. You can pour gas on the stuff and it comes back, and yet it's killed or greatly degraded by these electromagnetic fields. Dairy cows. More studies have been done because it's a $1 trillion business. It's not just milk. It's ice cream. It's cheese. It's butter. It's yogurt. It's sour cream.
This guy's gone full tin hat on us.
Full tin hat. So when you read the studies from the big guys, Dairy Gold, Marigold, all the way down to the Amish, all the way down to the Hutterites, the guys that don't use electricity, the measure of dirty electricity or the quality of electricity in a dairy is directly relevant to the production amount, taste, and quality of the milk. It has been so well studied. Here's another one. Greenhouses, indoor grows. We've got documented pictures of the plant moving towards the light or the water, moving away from the electricity. The plants don't like it. It's bad for plants. So because of the FDA, I can't say it's bad for you. So I won't. It's bad for grass, bad for cows, bad for strawberries. So wouldn't it just track what I'm not going to say? Wouldn't it just follow naturally?
So your device solves this problem?
Yes. Yes. And we're not full of crap. And it doesn't cut your bill in half, but it cools your crap down. It makes it a healthier, happier place for you and your crap and your plant and your cat. And your audio sound is crisp and your video picture is clear and your DVR is cooler and your phone charges hot and fast. It saves you a little bit on your bill. It's also a very robust surge protector. Lights don't dim. Alerts don't come on when the voltage drops from your neighbors. It's not, and there's no bleeding tech in it. I'm not the world's greatest guy. I started looking at my air conditioner and the capacitor went bad. So I had to become a friggin' expert in it because I didn't want to spend the $12. I'm weird. I got a surge protector on my stereo, and I got one on my friggin' air conditioner, but I don't have one on my panel. That's just stupid, right? And then I started looking into EMFs when my kid got sick. We moved into a house by power lines. And within 1 year, my dude had never had a B. My dude hadn't missed a day of school in 2 years, is now not being that dude anymore. So I immediately felt am a bad dad. Is something happening? And I started to go down this road. And I won't rabbit trail you guys too much farther on that. I'll just say our lighting has impacted our electrical world in a negative way. And the DC devices have impacted our electrical world in a negative way. And I'm not saying that anybody's to blame. I'm not saying that it's intentional. I'm not accusing any business or creature or anything. I'm just saying that it's measurable and it's measurably worse than before. And there are some outcomes from that. And one of them simply is your driver or your ballast will last longer if they operate within a lower temperature. When they get really friggin' hot, it just lowers their lifespan. And watts aren't free and heat's not free.
Greggy, before I go over, Greg's been pointing over to himself that he wants to ask a
That's
question,
fine.
but I just keep jumping in here. It's similar to when you want to dim LED device, any LED bulbs really well, and instead of having 12 all LEDs, you put one halogen bulb, and it makes the thing dim a lot better. One
Yes, it
resistant
does.
lamp on the dimmer really helps it go. Go ahead, Greg.
So that's exactly some of my questions. Lighting specific, that instance, I want to know that one. But then also going back to the printer, we do a lot of line voltage LED tubes, like a 4 foot. We're doing all commercial lighting for the most part. So an
Yep.
office building, you bypass the ballast, you put an LED tube in. That might happen to be connected to the printer, and it's happened, I would say, probably 15 times in the last couple of years to me, where we put in Type B tubes, which is bypass
Yep.
the ballast, and when the
Yep.
printer goes on, those tubes flicker. Is there ever a way to get that? Does your system cut that issue out, or would it?
Damn right.
Hmm.
Yes, it does. That's its job, stabilizing that voltage, separating things from inrush and the other things that happen. So anytime you have a switch mode power supply, um, anything that's sensitive downstream of that can potentially be negatively affected negatively. I'm going to use good grammar for you guys by the operation of that device. It's just a reality of the world, and we see it all the time. I'm just the weirdo that said, surely somebody makes something that can fix that. And really, it's here's another one. So you go into the stereo store, maybe it's Best Buy or something, and you see a really great Yamaha receiver, $500 or $600. Now, I'm a Yamaha guy. I raced for Yamaha, not a factory racer, but I rode Yamahas for a long time. I'm a Yamaha guy. It's the tuning fork company. Well, then you're in the mall and you see the Apple store and you see the Bang & Olufsen stereo store. And you go in there and that receiver is 12 grand. And you're like, are you out of your mind? I know that $500 Yamaha or other brands receiver is going to work great. And it is. It's going to work great. Why is the Bang & Olufsen 12 grand? It's that damn click or tick or pop in the speakers that you and I just lived through. The audiophile loses his mind over it. So he shields his wiring so he doesn't get interference. He uses these other things. So those are really the component sets that we began to look at in creating our device. And we really looked at the 8 aspects of alternating current that I mentioned earlier and said, okay, which component set treats each of these things? And then we began to see which of those would play nice together because some were competing. And we spent $1 million in several years finding and sourcing the best components that did each of these things and then getting them to play nice and building them into electronic that would work. And one of the challenges was this. In your electrical system in residence, you have 3 pathways. You have A to neutral, right? That's 120 volts. That's a unique pathway to itself. You have B to neutral. It's its own guy. But now you've got phase to phase, A to B, which is your dryer and your range and maybe your air conditioner. So our system treats all 8 aspects, but on all pathways, all 3 different pathways. So the surge protection and the components and stuff are different on the 240 than they are in the 120s. So all attributes, all pathways, those are our trademarks and our patents, and something that took us
So,
a long time to get there.
So going back to that one example, I just want to make sure now I can go solve it. Is it something you
Okay.
put on the outlet that the printer's connected to, or is it something that you put on the panel that the circuit goes to?
I didn't fully answer your question. I went down my own rabbit trail. So let's come back to, let's answer that, and let's come back to dimmers, and let's talk about that, because we got, so we make products that can either plug in, that are circuit specific. You don't need one for each device. Your bedroom or something is probably its own circuit. If you plug one in that room, you're getting that whole circuit specifically, but also in some way you treat it that whole phase. And so if you have our product in between what we call the culprit, the printer, the guy that's causing it, we call him a culprit, and in between him and whatever's being negatively affected, then it will fix that. We also make products that wire in at the panel that treat the whole panel. And that thing is going down in most cases the neutral. And so one of the things they did to fix that was increase the size of the conductor in the neutral, right? But that's like what I was saying before. Do you want to just put a Band-Aid on it? Do you want to put a filter on your cigarette, or do you actually want to stop smoking? Do you actually not want to get cut? So there's kind of two ways to go: acknowledge the problem and Band-Aid it, or acknowledge the problem and look to fix it. And there's two ways you can look to fix it. That manufacturer makes it better, or you filter it as close
See,
to
I
the
always
source as
thought
you
you
can.
could never do that if you didn't interrupt the power between the device and the circuit, like something you plug into the plug.
Right. It's so this is one thing that I'll say that I'm right about. I don't really know how it works. Alternating current is very confusing to me. How it goes forward and back and still covers distance. How it can be in several places at once. How
Nobody
you
really
can.
knows what electricity is, actually. That's the
I'm
truth.
telling you,
Nobody
bro.
does.
I have
No.
spent really okay. I have spent
Like that
so much time.
they don't even know what electricity is. I'll tell you that right now. This is going to
Okay.
blow people's minds, but there isn't a scientist in the world that can actually tell you what electricity is. We know how to harness it, we know how to generate it, we know how to use it. And so we have this downstream of it understanding of how it works and how much of it we need, but they don't. It's like light. Nobody really knows what light is. They don't even know what it is. They don't know what it does. There's all like light and electricity are kind of the same thing in a sense, and you couldn't. There isn't a scientist on the planet that could tell you what light actually is and how,
Hmm.
and if is it actually different from gravity. They don't even really know. And how does it create life? How does it grow? Like they don't know the answer to these questions. I've talked to them and asked them, they don't know what it is.
No, I love it. I love that, and I was sheepish too in telling you. I know how to fix it. I don't really completely
That's
understand
how
it. I
electricity
don't.
is. Nobody really knows. Maybe Tesla knew. Maybe Tesla knew. I
Right.
don't know.
You know
But
what is the
Edison didn't have a
electron?
clue.
What's the
They don't know
charged
what it is.
particle?
They can
So
observe the particles, okay? They can observe the
yes,
particles, but every time they observe a particle and they find it, there's one smaller. It's like the Higgs boson. After they get to the
right,
boson, they
right. We're
go
no
beyond
longer
that.
atoms. We're at quarks now. Yeah,
Yeah.
yeah.
So
Um,
they don't even know what it is.
so somehow electricity is all connected. So you know that in a way that when your neighbor does something, you feel it. So here's what's interesting about our boxes. Depending on how, so when you sell solar, if I was going to give you a pitch on it, what matters is not the friggin' sun. The sun comes up in much as Canada as it does in Texas. The day might be a little bit shorter, but solar panels actually want to be cold. They don't want to be hot. So, like Montana and stuff is fabulous for solar because we get this blend of big skies and cool temperatures. They want to be cold, okay? If you're going to sell somebody solar, the friggin' sun's going to come up on the earth, right? What matters is what you pay for electricity. If you pay 4 cents a kilowatt hour, solar sucks. You pay 25 cents a kilowatt hour, solar rocks, baby. We're talking 5-year ROI.
Eh,
What?
you know what? I don't want to get into a solar conversation because
Let me finish. I'm
okay.
going somewhere else with this. That's it. I'm just going somewhere else with this. But we're a solar dealer, and what you pay for watt makes a big difference. What makes a big difference in our product line's efficacy is the same thing, how your utility company bills. So most utility companies say on their website or somewhere else that they bill on the watt, not on the total power, not on the VA. Wrong. I'm calling grade A malarkey right now because we've done things with people's bills and stuff that mathematically doesn't work. But I'm not saying once. We got 85,000 installed. I've been slugging it out for 13 years. I got more power bills than man, I got as many as their friggin' utility. This is my life. I take it seriously. I'm not full of crap. I love people. I want to do good things. My son was negatively affected by it. I care about my fellow human beings. And if I can save you a couple bucks along the way, I will. And I'm telling you, utilities bill so differently and oftentimes so differently than what we're told they bill by, that oftentimes the result is a lot better than it should be, not based on the efficacy of our equipment specifically, is how the utility is billing you, where their tiers are, whether they're billing for
we
power
could have
factor.
a whole conversation on utilities.
Okay.
Trust me.
All right.
But let me make you a proposal, okay? You send me a care pack of your gear. You tell me how to measure and verify it pre and post. And I'll do that at my house. And my house is a good place to go because I have a 6-ton heat pump in my basement. I have a generator. It's a big house. It's got lots of different loads on it. And I will do the pre and post test, and then we'll do part 2, and we'll get really wild.
Done.
How's that sound?
Awesome. I want to know what I get for winning or being right. Come on now, because I'm going to send you $5,000 worth of gear.
The host of the Get a Grip on Lighting podcast will believe you.
Oh, what? Oh, and all my dreams will come true.
Yeah. No.
So we'll do that. I have no problem putting my money where my mouth is.
Okay.
It's measurable, and then we'll go down, some of the other things.
And if you can't see what you would get, you probably shouldn't be in business. You know exactly what you're going to get.
I know exactly what I'm going to get,
brother. Yeah.
Well, and
5,000 people who are lighting distributors are probably going to listen to this.
You know that I played this game a lot of times, and you know that I wouldn't do it if I didn't know what the result was going to be.
Yeah, sure.
And I'm going to tell you what the result's going to be, and I'm going to be so close that I'm really going to blow your mind. So we do have 85,000 installed. So one of the reasons, I've got a really great testimony I'd love to share about LEDs. The Tampa, Florida International Airport. So one of our guys, SEI, Scientific Energy Improvement, is the LED retrofit guy, right? So he's selling the LED retrofit. He's going to sell on 3 things. It's going to look beautiful. It's going to last a long time. It's going to save enough money on your bill to repay for itself within the life of the bulb. That's basically LED retrofit sales pitch. It's going to look beautiful. It's going to last a long time. It's going to pay for itself within the life of the thing. Okay, so he does a wing or something. I'm in Montana. I'm not disingenuous. He does a wing or a terminal or something in this LED retrofit. It's about $250,000. Well, he uses our boxes when he does it for a couple things. Number 1, it's going to make them last longer. And number 2, potentially help on the bill. So by adding our stuff, he helps 2 of his 3 things. It's going to save on the bill. They're going to last a long time. Our stuff helps with that. So a lot of the LED retrofit guys get one of our boxes at dealer cost, which is exceedingly low because we're the manufacturer, and add it, hoping to get that great result. Well, there was some kind of big surge. Was it lightning or whatever? I don't know, and I'm not full of crap. But there was a big surge, and like 20 electrical panels in this wing of Tampa, Florida International Airport saw a catastrophic spike and ruined a bunch of their crap. The panels that had our box didn't even show an anomaly on the data recorders downstream. The facilities director says specifically, I don't write fluff letters, but I got to tell you, this is the best, few $100 we've ever spent, because not only did it just save our $250,000 lighting retrofit, but it saved everything else on there. And so when you're talking LED, when you're talking driver, you're talking about major capital investment. You're talking about long life. You're talking about save and dough. And I'm telling you right now, stuff wants clean power, doesn't want dirty. Stuff wants to be cool.
Especially electronics.
Doesn't want to be hot.
Especially
electronics.
Yeah. So let me jump in here first, okay? First of all, when LED manufacturers tell me about lightning strikes and voltage surges, I call bullshit on that. Okay? But because then lightning strikes buildings all the time, actually. It's not like striking a human being. Buildings are like an airport is going to get struck by lightning probably 3 times a year, okay? To be honest with you. They get struck by lightning a lot. And, when you had metal halides in there or you had fluorescence in there was never any problems. And so the LED manufacturers are always using that voltage surge, dirty power to get out of warranty work. Okay, which probably has nothing to do with the lightning strike or that. But
Well,
I believe you. I think that you're onto something. I think you're right about everything you said. I just am not sure if your device solves those problems or not. You understand where I'm at right
of
now?
course I do.
I think you're right about everything you've said. But I need to see it to believe it. And then if we do, I think it goes with every LED lighting retrofit out there, Greg.
Sure could, especially those bypass ballasts that I have all the time.
Yeah.
So what I would say in response, I'm not a driver manufacturer, so I'm not
Mhm.
contesting what you say. I'll just add this: what I believe is that the driver is so sensitive that it is a voltage spike or something that takes it out. That needs to be covered in the effing warranty. If you make me something that's exceedingly fragile and it's going to break, if something that happens all the time happens, that needs to be covered in the warranty. Drivers are more sensitive. So if we know that it's going to fail, why are we giving them a pass on something that almost inevitably at some point is going to happen? That's my rebuttal to that. I think that surges and spikes do kill drivers. I just think that they should either build a surge protector in it, they should make the component more robust, or they should cover something that's likely going to happen within that 5 or 7 year. That needs to be covered because that's why I friggin' bought it,
Or they should kiss my ass.
right?
BD Erickson the second. You'll be on again. I don't know when, folks, but we're gonna do round 2 with BD after we run the tests, and then all you lighting distributors out there can get excited about scrubbing that electricity. Greg, but before we go, we gotta keep it easy, brother. We gotta keep it
That's right.
easy with KeystoneTech.com. That's KeystoneTech.com. That's light made easy, Greg Eric.
You know, we talked a lot about drivers today, and Keystone is a driver manufacturer. They actually have their own driver, which a lot of other LED manufacturers don't have. The importance of having a good driver is there, and they have it in all their fixtures, including their power and color selectable LED high bay. Change the wattage, change the color right on the fixture with a Keystone driver.
Ooh, yeah. Keep it easy with Keystone. Go to KeystoneTech.com, KeystoneTech.com. And of course, the National Association of Innovative Lighting Distributors. That's right. We're all going to start cleaning power if this guy on the next show, if we'll get it going, we'll keep it going. And then you'll be scrubbing everybody's electricity from here to Kalamazoo. And if you've made it to the end, folks, hey, you know I speak on behalf of BD, Greg, and myself when I say love you guys and gals out there that listen every week to the show. We appreciate you. And if you haven't joined Nailed, well, we're not going to let you in anymore. So just kidding, of course. Come on in. Join us at nald.org. Thanks for listening.